Needing to figure out how many northern pike, a certain type of fish, live in Little Lake Hubert, scientists caught, tagged, and released 121 northern pike in the lake. A week later, the scientists returned and caught 50 pike, 22 of which had tags. Approximately how many northern pike are in the lake? In our initial reading, I'm just taking away the fact that we're dealing with a certain type of fish, the northern pike, and we're trying to figure out how many of them live in a particular lake. I'm not paying attention to the specific details of how many have tags and how many do not. When we read the question a second time, we'll notice that we have two different times. There's the initial event where the scientists catch, tag, and release 121 pike. Then there's a second event, a week later, where they come back and 50 fish are caught, 22 of which have these tags. Those two separate events become the two ratios that we're going to need to work with. The second one we were given, the week later event, actually has all the information that we need. On this event, we know that there were 50 pike, and of those 50 pike, 22 had tags. We're going to use that comparison to help answer this question. Before we go any further, though, we do need to formally define our variable. The question we're trying to answer is approximately how many northern pike are in the lake. I'm going to let P represent the total number of northern pike in the lake. Now that we have a variable to represent the unknown and the answer to the question, I need to go back and set up an equation. We already know in one situation we have 50 pike, and of those 50, 22 are tagged. Again, it is important to keep track of the top value is the total number of fish, and the bottom value is how many were tagged, so that when I set this equal to another ratio, I keep that same structure. In the second ratio, I don't know how many northern pike are in the lake, so that's where our P comes in. But I do know from the very first bit of information that there are 121 tagged northern pike in the lake. So again, our second ratio still follows the total is on top and the number of tagged fish in the lake is on the bottom. There are two ways to solve the equation. 50 over 22 equals P over 121. We could use the standard approach we've been using for all proportions, where we multiply both sides by both denominators. But I also recognize the larger context here. I'm trying to solve for P. Right now, P is already isolated on the right side of the equation, and all I need to do to eliminate any other number from that side is simply multiply both sides of the equation by 121. To multiply 121 times 50 over 22, we will again make use of our calculators. To put this into the calculator, 121 times 50 divided by 22, our calculator returns 275. This tells us that P is equal to 275. As always, I want to check, did this actually work out? Is having 50 pike, 22 of which have tags, does that equal the same ratio as 275 pike, 121 of which have tags? Again, I'm going to make use of the calculator to complete this calculation. So on the left side of the equation, we have 50 divided by 22. The calculator spits back 2.27272727 and so on. We'll write that down as 2.27 with a bar over the 27. And then we'll check 275 divided by 121, and we notice we have the same value, 2.27 with that 27 repeating. So again, we will write that as 2.27 with the bar over it. Our check has now confirmed that the small sample a week later that had 50 pike and 22 of which had tags is the same ratio as the entire lake that has 275 fish, 121 of which have tags. So we're ready to answer the question. Approximately how many northern pike are in the lake? There are about 275 northern pike in the lake. It's important to point out I did include the word about in my sentence, even though originally it was an equal sign, which indicates these two values are exactly equal. Mathematically, there's some things happening behind the scenes here. There's an assumption that the distribution of the fish a week after the fact of that initial tagging is going to be the same as the distribution of the fish when we made the first initial tagging. In that week's time, things could have changed. Fish could have been born, fish could have been eaten, fish could have been caught by fishermen. So there is an assumption that these are going to be equal. In all reality, they're probably not exactly the same, but it's close enough to give us an estimate of what's in the lake. That's why we use the word about in our answer here.